Hello, welcome to another episode of Naked Neuroscience, the podcast exploring the workings of the brain and the nervous system in our bodies and beyond. I'm Katie Haylor, and this month...
we should view sleep in the same way as we would view healthy eating or getting enough exercise and physical activity. It's just as important to our health and well-being.
Have your slippers and dressing gown at the ready. We'll be nosying into the neuroscience of nodding off, asking, are we really taking sleep seriously enough? And should we change the way we view it? Plus, we'll be sifting through the latest neuroscience research with the help of some local experts. Let's jump straight into some naked neuroscience news. Joining me this month to cast their eyes over the latest neuroscience papers were Duncan Astle from Cambridge University and Helen Keyes from Anglia Ruskin University. First up, Helen looked at a study investigating whether standing or sitting affects the taste of food. Now, confession time, I always eat my breakfast standing up, so I was particularly interested in this one.
They wanted to build on the background of research that shows that all sorts of different sensory information can affect your taste perception. So in particular, your visual and auditory senses affect how you perceive the taste of food. So the appearance of food, and even something like a crisp sounds crispier, you experience the taste as more intense and flavourful. So they wanted to see whether sitting down or standing up can also feed into that taste experience.
And how did they go about trying to look at this?
They theorised that standing up would put greater physical stress on your body. Your muscles will be working harder to keep you upright, and also your heart will be pumping faster and harder to get the blood back up from your feet to your body. So they hypothesised that this physical stress would dull your sensitivity. We know that in general, physical stress dulls your experience of pain, response to flashing lights and loud noises. So they wanted to see whether it might also dull your taste perception. And there's a theory that this is because stress hormones, perhaps caused by this physical stress, can slow neural connections in your brain. So most studies, when they want to induce stress, do really nasty things to you, like make you put your hand in a bucket of ice cold water, or even inject you with cortisol, which is the stress hormone.
Didn't we speak a while back about people being forcibly kept awake as well?
That's right, another really nice way to do it. But these authors were much kinder to their participants, and they induced physical stress simply by asking you to stand for 15 minutes. So it's a nice, kind study. And then they ran a number of experiments. They tested 350 participants, and the participants very simply were either sitting down or standing up. And they were asked to rate a pita chip on a deliciousness scale, so on a scale of 1 to 7. And they found that the participants that were standing up rated the pita chip as significantly less delicious than the participants that were sitting down. Now, there's a huge amount of factors that could explain that finding, so they ran some follow-up studies to see if it was this physical stress driving this effect. First of all, they thought, well, some people might associate eating while standing up with being in a rush.
Like me with my breakfast.
Exactly. So they measured if participants were eating more quickly when standing up, and they found that they weren't. So that probably isn't what's driving the effect. They also wondered whether people, when they're standing up, they're in physical discomfort, so they might be paying more attention to their body sensations and therefore be a bit more distracted from tasting the chip. And they found that that wasn't the case either. People didn't rate themselves as paying any more attention to their body when they were standing up versus sitting down. So it's likely that with those explanations ruled out, it's probably the physical stress driving this effect. They also ran a really neat follow-up study looking at whether this is just a negativity effect. So if you're standing up and if your body's under physical stress, do you just rate food more negatively? And they found that that wasn't the case. When they asked their participants to eat unpleasant food, they made brownies, and some of those brownies had been made with a recipe involving half a cup of salt added into the brownies. They found that the people standing up rated those quite favourably. They didn't notice the unpleasant flavour of the salt. So basically, it's not just standing up makes you rate all food more negatively. It's that standing up and that physical stress seems to dull your taste perception.
This is very interesting. It's something I'm going to take away from my dietary habits. But What are the take-home points?
Well, a nice little side finding is that when people were standing up, probably because their taste sensation was dulled, they consumed less, both of food and drink. So one take home might be, if you really want to go on a diet, perhaps eat your food standing up, and you might just eat less of it. But the real take home message is that all of our mothers were correct, that we should definitely sit down to eat food if we want to enjoy that experience of food and appreciate the deliciousness factor of food.
Duncan?
I was just wondering if we think we'd get the same thing if it was a different type of stress, like emotional or psychological stress.
I think that's a really good question. And if we're talking about short-term stress, so any stress where cortisol, a burst of cortisol is released, we would expect to find these same findings. If the effect is being driven by a cortisol flooding of the brain, which is perhaps slowing your neural conduction, we might expect any sort of stress to produce the same effect of dulling your taste perception. However, we do know that longer term stress can have different effects on your body, the way your body stores fat, and you can put on weight that way. And longer term low level stress can also cause some people to overeat. And so we probably would expect a short term similar effect for any sort of stress, but not a long term effect.
Helen Keyes there. And that paper was published in the Journal of Consumer Research. Now, Duncan's paper this month was about, and I quote, mice, autism, and poop.
Every few years in neuroscience, there are these real crazes surrounding new topics or approaches. And one of the current crazes is around the gut-brain axis. The idea that the microorganisms that live inside your gut can release neuroactive substances which will influence brain activity and thus your behavior. And people are undertaking studies on all sorts of disorders like irritable bowel syndrome, depression, anxiety, schizophrenia. And the basic approach is to take fecal samples from individuals who have those conditions and then transplant them into mice and see whether the mice display similar behaviors to the donors.
Okay, so talk us through what they did.
So in this study, they took samples from individuals with autism and they then transplanted those into a small number of mice. They then checked that the mice's gut had been colonized with the bacteria in the sample, and they then observed the behavior of those mice, and they observed that the mice who had had transplants from individuals with autism spectrum disorder, or ASD, displayed more repetitive-like behaviors and differences in socialization, relative to mice who had received transplants from donors who didn't have autism spectrum disorder.
Okay, so are autistic behaviours displayed in mice necessarily an accurate reflection of people's autism?
Well, this is the million-dollar question, really, with this paper. So there are all sorts of methodological issues. So it's a handful of mice. So it's a tiny, tiny sample size. And it's very hard to imagine what the mechanism might be. But beyond those kinds of problems, there's, I think, a deeper problem, which is that we can barely agree upon what constitutes autism in humans, let alone mice. So we already know, for example, that in some individuals, the mutation of a single gene can result in autism-like behaviors, whereas in other cases, autism can be highly overlapping with other conditions like attention deficit hyperactivity disorder or language impairments, and we don't really know why that is. And the symptoms that a human who has autism can have can vary widely in scope and in severity, right from kids who might be entirely pre-verbal, so they can't use language, all the way to individuals who are extremely high functioning. And we're just trying to grapple with the complexity of what having autism means for a human being. So the idea that in this study they've managed to demonstrate that they can induce autism in these mice, it's kind of scarily simplistic.
Do we know how long-lived the effects were?
So they're short-lived because later on they reversed the changes in the gut ecosystem that they'd induced with the transplant, and thus, according to the paper, they changed the behavior of the mice back again.
Considering these challenges you've pointed out, what do you think the value of this kind of approach is?
I think there's some really careful work to be done here to start thinking about the mechanism by which what goes on in our digestive system could influence what's going on in our brain. But I think that we're an awful long way from starting to think about how that might influence really complex kind of multi-system disorders like autism. I also think there's a real problem where we try and create animal models of a human condition. I think we've really reached the age where we should stop doing work on autism that doesn't take into account the perspectives of people who actually have autism.
Is there precedent for doing this kind of experiment with slightly less complex conditions?
There is, so something more like IBS, where there's a more clearly defined etiology and pathology, and we have a much clearer idea of the mechanisms at play in producing something like IBS than we do with something like autism.
Duncan Astle there, and the paper he was talking about has been published in the journal Cell. If you want to read up on those stories in more detail, you can find the links on the Naked Scientist website, nakedscientist.com/neuroscience. And if there is some neuroscience news you want us to look at, or you've got a question you'd like us to address, get in touch. You can email neuroscience@nakedscientists.com.
You might not associate grassy banks with the coast.
It is a bit like stepping abroad for a second.
I'm here on the Ningaloo Reef, take people swimming with whale sharks.
Just another day at the office.
Yeah, just another day at the office, mate.
I have you loud and clear.
Hello.
Welcome.
The Naked Scientist podcast takes you to the science topics you need to hear about.
Physics, medicine, nature.
Keep up to date with what's going on in the field.
First this week, the announcement from LIGO.
And find out the answers to every question you never thought to ask.
What kills more people, sharks or selfies?
To subscribe, search Naked Scientist podcast or head over to our website.
We spend a third of our lives doing it. It's essential for physical and mental well-being, but many of us feel we're not doing it right.
The average amount of sleep that people are getting is reducing. The evidence shows that in terms of hard physical and mental illness risks, you should be getting at least 7 to 8 hours a night. And within that, I should say that everyone varies. Some people will need 10 hours, some people need 6 hours. But you should try really to plan your life around getting adequate sleep.
So grab some cocoa, get comfy and tuck yourself up with a blanket, because this month we're sounding out sleep. I'll be asking 3 experts, should we be changing the way we consider snoozing? Unfortunately, pretty much everyone has probably had sleep issues at some point in their lives. For some, it's a nuisance, and for others, it can be a literal nightmare. But could changing the way we think about sleep itself actually help us to sleep better? Paul Blenkiron thinks so. He's an NHS consultant psychiatrist and a member of the Royal College of Psychiatrists.
When I look back at a survey that was done back in 2010, which is the Great British Sleep Survey, this showed that about a third of people have chronic insomnia. They've had difficulty sleeping for at least 2 years. Research shows that people physically get more problems with diabetes, obesity, high blood pressure if they don't sleep as much as they would like to or want to. And also there are mental health problems linked to sleep problems, such as anxiety and depression, or simply just not concentrating during the daytime.
Is it possible for you to summarise what kinds of issues people can have with sleep? Because it's not just not getting enough, is it?
That's right. Sleep could be too much, it could be too little, or it could be broken or just dissatisfied for people. Sleep really is part of our sleep-wake cycle, and that's linked to stuff in the brain that controls our daily routine. So there's a group of cells in the brain called the hypothalamus, produce this hormone called melatonin. This is a hormone that makes you sleepy, and you produce more of this melatonin when it gets dark. So, of course, when it gets to the light times of the year, such as the summer, people sleep less. In the winter, they sleep a bit more. It's sometimes people's perception of sleep, which is the problem, rather than the actual amount. And people normally wake up during the night for 1 or 2 minutes, a couple of times a night, so-called micro-wakes, and we're normally not aware of those. But if you're bothered by your sleep, you're going to pay more attention to those periods of waking up. And of course, that sets off this vicious cycle of worrying about your sleep.
At what point would a psychiatrist like yourself come into contact with people who are having sleep issues? Because I'm guessing this goes a little bit beyond the sort of common sleep hygiene type routine stuff that people might be more familiar with.
Relatively few people with sleep problems will come to see a psychiatrist. I would tend to see people who had problems due to a mental health problem that was linked to sleep, such as depression or anxiety or some sort of stress. But a lot of GPs will see sleep problems quite commonly, either leading to mental health problems or mental health problems leading to sleep. In depression, we know that people have poor sleep, they sleep too much or too little. But of course, if you're not sleeping already, you become depressed. In that survey I talked about, 80% of people had low mood due to their sleep problems. 75% had poor concentration, and half had a relationship problem. So I think it's a bit of a chicken and egg situation. It can be difficult to disentangle those, even for somebody like me who sees quite a few people with this problem.
So, from a mental health perspective, are there particular elements of sleep that you would pay particular attention to?
There's quality and there's quantity. First of all, dealing with quantity, we know that as you get older, you need less sleep. Newborn babies, perhaps 18 hours. Adults, like you and me, probably 7 to 8 hours for a good, healthy night's sleep, and even less as you get older. And of course, Margaret Thatcher famously needed only 4 or 5 hours a night of sleep. So I tend to look at people's expectations of sleep as much as the content.
And could you just describe for us the various stages of sleep and what the brain's doing throughout the night?
We have two main types of sleep, slow wave sleep and REM sleep, or rapid eye movement sleep. The REM sleep periods last about 60 to 90 minutes at a time. They get more common as the night goes on. And during those periods of time, you are sleeping lighter than before and more likely to dream during those periods. People, if they're woken during slow wave sleep, tend to be really irritable, disorientated and confused. And in REM sleep, if they're woken then, they'll probably remember the dreams they've been having.
Is there any connection between the quality or quantity of dreams and mental well-being?
Well, this is a fascinating area, and of course it was Sigmund Freud more than 100 years ago who said that our dreams are caused by unconscious impulses, unfulfilled wishes. I think there are a few mental health professionals these days that would really interpret dreams in the same way, but we do know that people are bothered by dreams sometimes. If you've had a traumatic experience in your life, you might get flashbacks or nightmares to that trauma, and it might come out in the dream. But for most clinical people, I would say they're not really so concerned about the content unless the patient in front of them is concerned about it. They're more concerned about the overall quality of sleep. And dreams can be affected by mental health problems and by certain medications.
What can be done to help people who are suffering from bad sleep? What might you be doing as a psychiatrist?
First of all, address the cause of the sleep problem. So common sense tells you that if you've got a noisy room or your partner snores, that's the issue that should be dealt with. If there's some sort of heart problem that's keeping you awake or some sort of asthma, then get that treatment. So first of all, deal with the cause where possible. The second thing to do is to look at lifestyle changes, something that's called sleep hygiene. So even before people see me, I'm sure their GP will have given advice on avoiding caffeine and alcohol, using the bedroom just for sleep and little else, and generally making sure there's a regular routine. When they get to see me, I've got two sort of interventions I could offer. Medication is one possibility, but a better, more long-term solution is to consider cognitive behaviour therapy.
So this is actually changing the way people are thinking about sleep or the reasons why they're not sleeping. Is that right?
That's a good summary. The B part, first of all, is about your behaviour. So often we might get people to keep a sleep diary. And for example, if they're only getting an average of 5.5 hours sleep, we get them to go to bed a bit later than normal, maybe 1 a.m. if they need to be up for 7 a.m. The key thing here is not to sleep in the morning and to train yourself to get up after that 6-hour window. The C is cognitive, which is how you change your view of sleep. We all know from sleep problems that when we're lying there in the middle of the night, these unhelpful thoughts keep going round our head. I'm never going to sleep. Everyone else is sleeping. I might go crazy if I don't get enough sleep. And the idea of CBT is to encourage people to have more helpful and realistic thinking. So I might encourage people to train themselves to say in the middle of the night, this doesn't matter. I can function well enough without sleep. I'll sleep better tomorrow. I'll fall asleep when my body is ready. The key thing, of course, is not to actually try and get to sleep, because if you try really hard to push a thought out of your mind, back it comes again. So we practice a form of psychological adjustment called mindfulness, letting your thoughts stay with you and being okay about that and being, so to speak, chilled out in bed and ready for sleep when it takes you.
How effective can this cognitive behavioural therapy be, first of all? And also, does having a pre-existing mental health condition just make
you for the night? And this body clock essentially interacts with what we call the sleep homeostat, which is essentially the body's way of counting your sleep need. So as we wake up in the morning and we'll sleep, we'll hopefully have a good restful night's sleep. And then over the day, we will accumulate what we call sleep pressure. That will be maximal in the evening, and that will make us sleepy. And then as we sleep, this sleep pressure dissipates and goes down again to a level which means that your sleep homeostat is satisfied, you're ready to wake up again. It's a way of describing a biological need which in many ways is similar to hunger and thirst, for example.
Why might my biological clock be different to my partner's then?
Again, this is due to this biological variation that we have, to a significant part due to genetic differences. To put it simply, we have body clocks which take a little bit faster or a little bit slower than other people's. And of course, then there's many of us who are somewhere in between. So a fast body clock would make us what we call a morning type or a lark who naturally wakes up early and prefers to go to bed fairly early as well. And the opposite of that would then be somebody who has a slower body clock, who is what we call a night owl. So this would be an individual who has a natural propensity to stay awake longer and to sleep in longer in the morning.
We've known about these body clocks and the differences for a while now. So what new research is coming out about the health consequences of not necessarily paying attention to those body clocks? Because in modern life, it can be actually quite difficult to find time to switch off or switch on, as it were, at the appropriate time of the day.
Indeed. We know from a number of studies that sleep deprivation is not good for your physiology. Sleeping out of synchrony with your body clock is also not good for you, such as in jet lag or in shift work. But there's also a growing body of evidence that people who are night owls naturally have a bit of a raw deal in terms of health outcomes. So there is a number of reports showing that on average, night owls have a higher risk of having a poorer mental health and poorer cardiovascular health, and also higher risk of diabetes. In a report that we published last year, we used data from the UK Biobank, where middle-aged people, when they signed up for this study, they answered a question about, are you a morning type or an evening type on a scale with 5 steps? And what we found that people who describe themselves as definite evening types, during these 7 years, they had a 10% higher risk of dying than the definite morning types. And it's really important to note that we have no reason to assume that there is something intrinsically unhealthy of being an evening type. What we think is happening is that evening types who are essentially forced to live in a world which is designed around the preferences of morning types, they have a difficult time, because if you find it hard to fall asleep until quite late, but you still have to get up as early as everybody else, then you will start accumulating a sleep deprivation, which in the longer term is detrimental to your health. And equally, you can end up with something called social jet lag, which we often see in evening type. And that means that in the weekend, they essentially try to make up for having to sort of live against their natural inclination by almost sort of traveling to a different time zone, by sort of moving their activity patterns over the weekend and then back again on Monday. And that also is not good for the health.
How can we better accommodate these sleep differences then?
It is really important that we have an open dialogue about this in society, and that we recognize that this natural biological variation is nothing to do with whether you are industrious or lazy or anything like that. It is just our biological background. Now, there are, of course, some professions where there is no flexibility, but in many professions, it is possible to have flexible working hours. And fortunately, people are now openly discussing flexible working hours for reasons such as care responsibilities. It should absolutely be an acceptable reason to ask for flexible working hours. If it is not detrimental to your availability for meetings, etc., why would your employer not want you working during the 8 hours when you are at your peak?
Now, napping is something we tend to associate with kids or babies. Is there any evidence to suggest the benefit of an adult nap if your body clock doesn't necessarily complement the standard 9 to 5?
Well, if you need a nap, then get it. It's not as good necessarily as getting the sleep at the appropriate time, but there's lots of evidence showing that even a short power nap actually can help us function better for the hours subsequent to that.
Malcolm von Schantz there from the University of Surrey. We've heard how getting enough good sleep plays a vital role in our overall health. And one area a bad night is particularly noticeable is in learning and memory.
There's a tendency in our culture that if we're really busy, we can just reduce the amount of sleep that we get, and that will kind of give us some free extra time to do some of the things we want to do. However, sleep is about far more than just feeling tired and fatigued during the day. More than that, sleep is actually actively involved in the way that we learn and consolidate new information in our long-term memories.
That's Anna Whale. She's a cognitive psychologist from the University of Sheffield and on the executive committee of the British Sleep Society. First up, Anna explained to me how sleep helps to integrate new information learned that day into pre-existing information stored in our brain.
We, as human beings, children or adults, can learn new information really quickly and easily. So, for example, we might learn a new word. I'll introduce one now. For example, hippocampus. Hippocampus is a little part of the brain, the shape of a seahorse. It's really important for memory. And in particular, when we learn something new, like the new word hippocampus, we'll initially store it there. So that happens while we're awake. Imagine we've learnt this new word and now we need to put it in our mental dictionary with all the other words that we know already. Well, what seems to happen during sleep is that the new word stored in our hippocampus, which is like a temporary bit of memory, if you like, transfers into our long-term memory, which is stored in the neocortex. And it looks as though sleep actually facilitates, it helps the links between the immediate memory in the hippocampus and our long-term memory in the neocortex.
Can we see that effect happening in the brainwaves?
Yes, so we can see it in several different ways. Thinking about the brainwaves, in a sleep experiment, a researcher might invite participants to come into the lab to learn some information and then to stay overnight or to have a nap in the lab. So your brainwaves will be recorded. We can then look the next day at how well the participant remembers the information they learned previously, and we look to see whether they remember more or less than they did before they went to sleep. And we can then look for associations between the brain activity, so how much of certain types of sleep did you have, and we can look for a relationship between that and how much you remember the next day. Spindles are little sharp spikes in the electrical activity that happen during that slow wave sleep. Neuroscientists believe that those are associated with transmission of information and the connections from the hippocampus to the neocortex.
So now we know why sleep is important for memory and learning. What effect can suboptimal sleep have then on someone's ability to remember something?
Not having enough sleep or learning information and then not sleeping on it might cause you to forget more of that information. It will depend, of course, on what that information is. Just occasionally having a poor night's sleep, I don't think we need to worry that that's going to drastically affect our memory. However, we do know that if people are tired in the short term, it will affect their performance on a given day. So it might affect their ability to encode memory because they're tired. And over time, if people are consistently sleep deprived, then again, that can affect their memory abilities.
Most people are probably aware of general sleep hygiene, things that are common sense, a good idea, sometimes difficult to implement.
Yeah.
Does it go beyond that?
So, especially with children and young people, encouraging them to have good sleep habits is a really good place to start. At the University of Sheffield, the hospital, and in collaboration with an intervention designed by the Children's Sleep Charity, they've shown that you can actually improve sleep by as much as 2.5 hours. You can increase a child's sleep by as much as 2.5 hours where they've been experiencing difficulties and where the family becomes involved in an intervention that improves attitudes around sleep and bedtime behaviour. That's actually a much bigger improvement than we've seen in the leading trial using melatonin, which is a hormone that's sometimes used to improve sleep.
If sleep is so important for learning and memory, is there anything about sleep that we can tweak to help us be better at remembering things?
This is a very exciting emerging area of neuroscience, I think, and we certainly still don't have all the answers. But a few researchers and a few labs now have demonstrated that you can actually change the properties of sleep using quite simple techniques. You can boost power of slow wave sleep, the depth of the slow wave, so you make the slow wave sleep perhaps last for longer and perhaps have more potential to affect learning and memory. So you kind of make that deeper sleep even deeper, perhaps, is a way to think about it. Using something called auditory stimulation, monitoring somebody's brainwaves while they sleep. And once they begin to enter a phase of slow wave sleep, they are played a noise, pink noise, which if you've heard of white noise, pink noise is basically very similar. It would sound similar if you heard it. It's just not quite as crackly. And what they do is synchronize the onset of this pink noise with the onset of the slow wave sleep. And by doing so, you can actually see these sleep waves changing in a measurable way. This is a very experimental technique and it needs further replication. But there is preliminary evidence that suggests that boosting slow wave sleep in this way can be associated with increases in memory recall for information that you learned before that sleep. So that's been shown in NAP studies with adults. And there's some very preliminary emerging evidence that there's potential for this sort of intervention in atypical populations, for example, children with ADHD. So there's still a lot to learn, but if that finding bears out, then that's potentially a very powerful intervention that might help people who have problems sleeping.
Anna Whale from the University of Sheffield there. And if you want to find out more about the pink noise work, there's a link to the paper on our website, nakedscientist.com/neuroscience. Now, when I asked the Naked Scientist office how they sleep, I got a rather mixed response. First off, here's our very own Adam Murphy.
If I could, I would be nocturnal. I'd sleep from about 4 a.m. to 12 p.m.
And Keita, how happy are you with your sleep?
I'd like to be able to sleep more. Definitely more of an owl. I work really well in the evening, so getting up in the morning is always a challenge.
Matthew, how well do you sleep?
On average, with exams, they're 4 to 5 hours a night. It's a little rough.
I'm probably a lark. If I could shift my hours to even earlier, I probably would do that.
I cannot even fathom what living like that is like. It baffles me.
Phil, how do you sleep?
100% owl. Harry Potter level.
So basically all of the Naked Scientists are owls, apart from Izzy.
Apart from Izzy Lark.
Apart from Izzy Lark. We like a pun in the Naked Scientist office, as I'm sure you're all painfully aware. Now, when planning this episode, I couldn't resist but ask the experts for their favourite sleep pseudoscience that they would like to myth bust. And I got my fellow Naked Scientist reactions to each of them. First up, cognitive psychologist Anna.
I really hate when people have forgotten something and they go, oh, I can't remember that detail because I've slept since then. Because we know that having slept should improve your memory of something, at least if it's important.
Izzy, have you heard that before?
No, but I also forget things quite regularly. And then throughout the day, I'll be like, oh God, I forgot to do something. And then I get to it. So, I mean, sleep has happened in the in-between, but perhaps that's just I should be more organised with my life rather than blame it on sleep.
No comment, Izzy. Next up is body clock scientist Malcolm Smith.
There seems to be an impression that you cannot make up for lost sleep, and that is manifestly not true. And then we talk about sleep debt, which almost is exactly what it is. So if you're sleep deprived, then if given the opportunity, your body will make up for that by sleeping longer for the next night or 2 nights. That is something that we should, whenever possible, just go with.
Adam, you looked really surprised.
I was convinced that sleep debt was a thing you couldn't make up, that if you lost sleep, tough. And I'm really glad that it isn't true.
You're not allowed to sleep at work, though.
I mean, you have to catch me first.
No sleeping on the job, Adam. And finally, here's a few words from psychiatrist Paul.
I know a lot of people who come to see me or go to the GP want a sleeping tablet to sort the problem out. I have to say that most of the time this is not going to be a good idea. The medications that we prescribe for sleep are meant to be taken for a maximum of 2, maybe 4 weeks and then stopped. So I would suggest to people, if their sleep problem has been going for a long time and there's not a specific reason for not sleeping, don't go for medication, go for lifestyle adjustment and CBT. Problems with the medication, of course, although they do work, drugs like Zopiclone do work, it is a short-term fix. Tends to cause dependence, tolerance. People tend to need more of the same drug for the same effect. And in the elderly, it can lead to problems such as confusion, more falls. So I would say if you're going on holiday and you have terrible jet lag or a shift problem, or you've had some terrible trauma in your life, by all means consider medication for the short term. But please, in the long term, don't look to it as a solution. Stay off tablets where you can.
Weirdly, I fall asleep on public transport. And also if I'm a passenger in a car. Does anyone else do that?
You can put me as a passenger in a car for a 20-minute journey and I will start to nod off. It's quite embarrassing.
I think we're just a bit weird, isn't it?
I have a partner with it.
Yeah.
Your wife does it as well?
Yeah. I wish I could sleep in a moving vehicle. I've never been able to. It's the skill I'd most like to have.
I'm not sure I'd call it a skill necessarily, Phil, but thank you very much. Thanks to the Naked Scientist office for being such good sports. And perhaps we should all take Paul, Malcolm and Anna's advice and make sleep a bit more of a priority. Thank you to Anna Whale, Paul Blenkiron, Malcolm von Schantz and Helen Keyes and Duncan Nassel. And thank you to you for listening to the show. That's all for this month. We'll be back next time with more Naked Neuroscience. In the meantime, how are you enjoying the show? Is the format working for you? What would you like to hear more of? Your thoughts are really appreciated, so why not leave us a review wherever you get your podcasts? Or you could drop us an email. It's neuroscience@nakedscientists.com. I'm Katie Haylor from the Naked Scientist team. Until next time, goodbye.